All right, so is this the example that we left off on? We did this one, the radical, right? It was a radical function. Okay, so we talked about finding the x-intercepts. How do you find an x-intercept? Set the y equal to 0, solve, right? How do you find a y-intercept? Set the x equal to 0, solve. Domain, what is it for domain? It's a set of possible x's. In this case, in radical functions, is there an issue with x's? Like, is there ever going to be a time where radical functions won't be defined? In this case, when? What can I never have underneath the square root? A negative. A negative, right? I can have 0 because the square root of 0 is still 0. But can I have a negative number inside of a square root? No. So then the only issue is when this is going to be negative, correct? So then to figure out your domain, you have to say basically, look, x plus 3, the radicand, has to be greater than or equal to 0. Does that make sense? Is that basically saying what? It has to be, what's the wording of greater than or equal to 0? How would you describe that? Has to be positive. Has to be positive. So then we figured out fine. If I subtract, so then x has to be greater than or equal to negative 3. We found then our domain. So this is one way of writing it. Or we said our domain is going to be basically negative 3 to infinity. And then the best way to find the range is with a graph. Okay, so with that graph, the lowest point it goes is to 0. The highest point is to infinity. Okay? We all good? All right, let's try this equation. Okay? And actually, we're going to need calculators, so do me a favor. So, do you guys notice anything different about this function than the last one? What does it look like it's going to be? It looks like it's going to be a radical function, right? Because it has a square root. Is that right? Is there a difference, though, with the radicand? It's x squared. So do you think that's going to change what this is? Absolutely, okay? It's absolutely going to change it. As a matter of fact, let's kind of jump the gun here, and I want everybody to graph it. I want to see what this looks like right away. So go to your y equals and plug in the square root of x, 25 minus x squared. 25 minus x squared. What is it? It's a semicircle. It's a semicircle. It's half a circle. Okay. Could I have known that beforehand? Kinda, if you were paying really, really close attention. Does anybody know what the formula or the general formula for a circle is? Like, how do you know what's a circle look? When you see the equation, you're gonna say, "Oh, that's a circle." Say that again. Is equal to what? Not 0. It was x squared plus y squared equals 2. It has to be a number, because if it was 0, that means that the radius is nothing, which means there's no circle. So it was x squared plus y squared equals to r squared. Y'all remember that? Right? R being your radius. Okay? How in the heck is that something like that? It's actually pretty simple. If I were to graph a circle in your calculator, if I told you graph the circle in your calculator, could you? What do you have to do, though? In order for you to graph anything in your calculator, it has to be what? Well, what button do you press? It has to be y equals. So it has to be y equals something, right? All your functions that you ever put are always y equals something, correct? So in this case, if I asked you to graph a circle, you would have to solve for y, right? So let's just real quick, this is kind of side note, but it's really important. If I ask you to solve for y, tell me what you would do. You would move x squared. So you would probably have y squared equals to r squared minus x squared, correct? And then what would you do? You would square root both sides. And you would get y equals to, now here's the thing though, because you square rooted, you would get plus or minus the square root of r squared minus x squared. Does that look like that? Yeah. It's exactly like that, right? Except in this case, my r squared is 25, right? So my r is obviously 5. Good. So my r squared is 25. The only difference is, notice how many equations are here? There's two, a positive square root and a negative square root. But over here, I'm only dealing with one. Which one? So do you realize that's why you only have a semicircle, right? You only have the top part. If I wanted you to have the bottom part, then I would have said, oh, and also the negative square root. Does that make sense? Okay. So this is a semicircle, which obviously comes from a circle. It's just half of it. I only pay attention to the half. Although the other stuff has not changed. How am I going to find an x-intercept? Yeah, I'm going to do the same stuff. So I'm going to make my y 0. So what is that going to look like? 0 equals the square root of 25 minus x squared. And then what do you think I should do? Square both sides, Mia says, right? If I square both sides, what happens? Still 0. Square root cancels out, so I'm left with 0 equals 25 minus x squared. Now what? So I could subtract 25. What's the problem with that, though? Then I'm still left with a negative x squared. Wouldn't the easiest thing to do would be to add the x squared, which would now make it positive x squared. Square root that, and what do I get for my x? Positive or negative 5. So how many x-intercepts does this semicircle have? 2. One at negative 5 and one at positive 5. We good with that? Any questions on that? All right. How do I find a y-intercept? Make x 0, right? So I have y equals square root of basically just 25. And what is the square root of 25? So here's the thing. You do technically get plus or minus 5. But remember, which part are we not paying attention to in this case? The negative version, because I only have a positive top part of the semicircle. Does that make sense? So I'm only going to kind of pay attention to the positive 5. So I only have a 1, 2, 3, 4, 5. So with this information, I can pretty much graph my little semicircle there. Okay? I can graph my semicircle. How am I going to determine the domain for this one? Where are your x's going to be? Basically, it's everything between negative 5 and 5. Does everybody agree with that? How can I write that? Tell me how I can write that. How do you write your x's between negative 5 and 5? There's two ways, and I'll take both ways at this point. So so I'm hearing, we're talking about the brackets, right? So let's start with the brackets. Brackets are the easiest one, I think. Okay, so remember, when you're doing the brackets, when you're doing domain and range with the brackets or parentheses, it's literally what's the lowest to the highest, right? Where do you start, where do you stop? So in our case, where do we start? And where do we stop? And then now we have to determine, okay, am I going to put a bracket or am I going to put a parentheses? What's the difference, by the way? Bracket is included, parentheses is not included. Do I want to include these points? Yeah, so then I'm going to have actually both brackets. So my domain is from negative 5 to 5. Is everybody good with that? Now, everybody else earlier was trying to explain, okay, so with the inequalities, right? Good. It looks like this. The easiest way, guys, just literally write your x between your two numbers, and it's always going to be this way. It's always going to be this way. However, it's not just less than or equal to, because I want to include those points, right? So x, negative 5 is less than or equal to x, which is less than or equal to 5, okay? And then for my range, again, easiest way to find range is to look at the graph. It's the easiest way, okay? So what's the lowest I go? 0 to what's the highest I go? So then, how do I write that? We can do both. We'll do bracket 0, comma, bracket 5, right? Can you write that this way too? How? We're dealing with range. Okay, guys, the reason I'm showing you both, right? On your homework, you don't have to give me both. Although on this one, on this first assignment, I would like for you to give me both, is because I don't know how the test is going to ask you, right? They could ask you with brackets or they could ask you with inequality, and you have to know what they mean both ways. Okay, so these are the two versions that you'll see. Any questions with this so far? Simple stuff, right? All right, let's kick it up a little bit. Actually, no. Next one's kicking it up. This one's easy too. Does anybody tell me what this function is called? Because this is y equals something, right? It's f of x, so it's only one function. But I'm assuming you're giving me that strange look because what's the problem here? Or what's the difference here? There's two parts, right? There's two. Does anybody remember what we call this? This is a piecewise function. This is a piecewise function. Why do you suppose I call it a piecewise function? Because I'm just going to use pieces of functions, right? And so basically that's what a piecewise function is. It's a bunch of different functions put together, but only the pieces, not the whole things. I can't just draw a bunch of functions because it'll look weird. So it's just little pieces at a time, okay? So the way you do that is just go through each one. Go through each one. So let's look at this top equation in my piecewise function. It's x squared minus 1. Can you tell me what it is? Like what function that is? It is quadratic. It is quadratic. What does it look like? What do quadratic functions look like? What is that called? It's a parabola. So it's a quadratic function. It's a parabola. Can you tell me something about that parabola? It is facing up. How do you know? Good. My a is positive, so it's facing up. Very good. What else happened to this function? Very good. It was moved down. How do you know it was down and not to the left or right? There's two ways to. There's only two things to do to a function. Movement, translation-wise. You can either move it up or down, or you can move it left or right. What's the difference? How do you know it's left or right? How do you know it's up or down? It's a very simple thing. Parentheses. If it's inside of parentheses, it'll move left or right, but remember it's always opposite of the sign. So if it was plus, you actually move left. If it was minus, you would actually move right. If there's no parentheses, or it's outside the parentheses, you go up and down, but you do exactly what it says. Plus goes up, minus goes down. Remember that? So side note. So this is kind of side note. What's the equation of a parabola that was moved 3 units to the right? So what's a parabola that was moved 3 units to the right? How would that look? Well, what do I need? Parentheses. X. Well, see, here's the thing. The squared goes on the outside. So it's x minus 3 squared. So do you see the difference? You see the difference? If you're going to go left and right, it has to be inside of parentheses. If you're going to go up and down, it can be no parentheses at all. So in our case, what happened to our parabola? Michael said it earlier. It's just down 1. Okay? So does everybody agree that I essentially have a parabola that looks like this? All right, so does everybody agree that this is what my parabola is going to look like, right? Because it was just my parabola shifted down 1. Agreed? Now, however, because I said I only want a certain piece of it, correct? I only want a certain piece. And they tell me which piece. What do they tell me? They only want the x's that are less than or equal to 0. So basically, they only want which x's? The negatives. So guess what I don't need anymore? The positive. So I only need that. Does everybody see how that works, right? So it's essentially, it's a full function, but I only need this piece of it. Does that make sense? All right, let's look at the second part of my piecewise function. What kind of function is that? It is linear. How do you know it's linear? Good. This is linear. And he said simply that the x doesn't have an exponent. So does that make it linear? Yes, it does. Actually, it has an exponent of what? 1. So it has an exponent of 1, so therefore it's linear. Is this in like my linear function form? What is the linear function form? The standard form for linear functions? Is it in mx plus b form? Sure is. So then you should be able to tell me two things. What's the slope of this linear function? And what's the y-intercept of this function? So you should be able to graph it, right? You should be able to graph it with that information. So you know you're going to have, what was this again? This was -1, so -2 down here. Okay, so you know that you're going to start at -2. And you're going to, do we have first lunch? Yeah. Oh. All right, so y-intercept of -2 puts me here, and then how do I get the rest of the line? I use my slope. What is my slope telling me to do? Go up 1 over 3, 1, 2, 3. Technically, it's that whole line, but again, the restriction on my piecewise is what? It wants what? X greater than 0, which means it wants all the positive. Now, if you were paying attention, you notice something interesting about it. Just says x is what? Greater. So does that mean something? Yeah, it means that here at 0, I have what? An open circle. Good. So it should be an open circle here, and it was a closed circle on the other one because it was inclusive of 0. Man, this video is going to have a bunch of fun stuff for y'all. Just intercoms and bells and interrupts, and I'm pretty sure I cussed already. Oh well. Any questions on this? What was this called again? Piecewise. Any questions on this piecewise? So guys, it's really simple. It's just look at every piece separately, put them all together, only take what they're asking for, okay? Is there a limit? Do you think there's a limit on how many functions I can have? Nope. Okay, so normally it's about 2 or 3, but it can be as many as we need. All right? Any questions? All right, let's get to the fun stuff. Let's see how good your memory is, okay? So, if you were summer pre-cal, this should be no problem for you. We're going to talk about our asymptotes, okay? We're going to talk about our asymptotes. There are 3 types of asymptotes. What are they? Horizontal, vertical, and slant. Very good. Do you remember how to find them? Let's start with the easy one. The easiest one is the vertical. Easiest one's the vertical. How do you find a vertical asymptote? Set the denominator equal to 0 and solve. So to find the vertical asymptote, you're going to set the denominator equal to 0 and then solve for x. And it makes sense because remember, if I'm setting the denominator equal to 0, that means that the denominator is 0, and do I want that? No, right? And that would be the undefined points, which would give me a vertical asymptote. Is everybody good with that? Now, here's the tricky one. Horizontal asymptote. And the reason it's tricky is because there's basically three rules for just this one horizontal asymptote, okay? You're going to be looking at the what? Exponent, more specifically the highest exponent, which is called the degree. Good. So for horizontal asymptote, you're going to compare the degree of each function. And so you're looking at them separately, okay? You're looking, because this is a rational function, correct? Because it's in a fraction, it's in a ratio. And it has essentially two functions, one on top, one on bottom, the numerator and the denominator. And what Becca's saying is you're going to look at the degrees. And there's essentially three things that can happen, guys. What are the three things that can happen when you're looking at the degrees? One is either they're going to be the same. The other is the top's going to be bigger or the top's going to be smaller. That's pretty much the only three options, correct? All right, so the first thing is in the same degree, right? If they have the same degree, okay, if they have the same degree, your horizontal asymptote is always, the ha is a ratio of, I'm going to write LC. And when I say LC, that means leading coefficients, right? So it's the ratio of the leading coefficients. And what are coefficients? The numbers in front of the x's, right? So for instance, if they were both x to the third power, but it was 3x to the third power over 2x to the third power, then it would be 3 over 2. Does that make sense? Right? So you're just looking at the leading coefficients as long as the degrees are the same. All right, so what's the second thing that can happen? Well, the top could be bigger than the bottom. Okay? And again, what do I mean when I'm saying top and bottom? I'm talking about the degrees, right? So if the top is bigger, does anybody remember what happens? Yeah, so if the top is bigger, actually no. If the top is bigger, there is no ha. There is no horizontal asymptote. If the top degree is bigger than the denominator, there is no horizontal asymptote. So then finally, if the top, though, is smaller than the bottom, then the ha automatically is y equals 0. Okay? Then the ha automatically is y equals 0. So let's recap. For horizontal asymptote, you have three instances. The first instance is that they have the same degree. If they have the same degree, what do? You're just looking at it's a ratio of the leading coefficients. If the top is smaller, what do? It's just automatically y equals 0. Top is smaller, it's automatically y equals 0. If the top is bigger, then there is no horizontal asymptote. Got it? Okay? So now, finally, let's go to the slant asymptote. So, first of all, the prerequisite, the requirement for a slant asymptote is that there is no horizontal. Okay? You cannot have a horizontal and a slant asymptote at the same time. So if you have no horizontal asymptote, then that kind of tells you there might be a slant asymptote, okay? And the way to find a slant asymptote, so to find your slant asymptote, you're going to have to use long division. You guys remember this? You're going to have to use long division, okay? You're going to have to, and remember, a ratio is simply division. So these are being divided, right? This literally means 3x squared divided by x squared minus 4. So they are being divided, but now I'm just going to actually do it. Okay, and I'm going to have to use a long division. And then, of course, how do you find an x and a y-intercept? Same way. To find an x-intercept, you make y 0. But because it's a rational, I'm only going to pay attention to the top. To find the y-intercept, you make x 0, and so forth. Okay? So, can I erase all this stuff and actually do it now? Okay. So, is there a horizontal asymptote here? Is there a horizontal asymptote? What are my degrees in this case? They're both 2, so they're the same. So, because they're the same, then my ha is y equals the leading coefficients. What are my leading coefficients? 3 over, which is just 3. So my ha is y equals 3. My ha is y equals 3. So that means at 1, 2, 3, I have a horizontal asymptote. Okay? So, automatically, one of these is already done too. Which one? The slant. What's the slant? There is none. Why? How do I know there's no slant? Because I have a horizontal. Does that make sense, people? Okay, so I can't have both. So if I have one, I automatically don't have the other. Okay? For a vertical asymptote, what do I do for the vertical asymptote? Set the denominator to 0. So I'll have x squared minus 4 equals 0. Solve. So what do I do? Tell me what to do. Add 4. Square root it. What do you get? X equals plus or minus 2. So how many vertical asymptotes do I have? 2. One at positive 2 and one at negative 2. Okay? One at positive 2 and one at negative 2. So does everybody see how this graph is broken up here? How many sections do I have here? There are 6 sections, right? There are 6 sections. So first of all, in general, what do rational functions look like in general? Just like, what's the parent function for a rational function? They're curves that are kind of opposite, right? So in general, if my equation was this, just 1 over x, it would look like this. Right? So what you got to get out of that is this. If you notice that unless there's some kind of manipulation, that they're always on opposite sides, right? So one's on top, on the left, the other one then is on the bottom right, okay? If I made this a negative, then they would switch, like right here, okay? So I'm telling you that because I want you to keep that in mind, because as I draw this graph, that's going to come in handy. So basically what I'm saying is if I have a piece of graph here, where will the next one be? Like if I have one here, the next one will be here at the bottom. And then the next one will be back up top. Does that make sense? And then vice versa. If I had it up here, then it would be up at the top, and then the other one would be at the bottom again. Okay? So they have to kind of switch like that. So just keep that in mind as we're doing this. So let's go on to the x-intercept. How do you find the x-intercept? Set y to be 0. Okay? So that, and by the way, because it's irrational, I only care about the numerator. So basically it's just 3x squared equals 0. Solve for x. Zero. Does everybody see it's going to be 0? Right? Because what are you going to do? What would you do anyway if you were to solve this? You would divide by 3, but 0 divided by 3 is still 0. And then you would square root of 0 is 0. So does everybody see I do have an x-intercept at 0? Okay? I do have an x-intercept at 0. Okay? For the y-intercept, what do? You make x 0. If I were to plug in a 0 for every x, what would I have on top? 0 over, what would I have on bottom? Negative 4. What is 0 divided by negative 4? So y equals 0. So by my x and y-intercept is the origin. Does everybody see that? My x and y-intercept is the origin. Does that help me determine what my graph's going to look like? Yeah, because if I know I cross here, doesn't that tell me that this middle piece has to be here on the bottom? Right? It has to be here on the bottom. And how do you, so then do you kind of have at least a good idea of where the others are going to be? Where? On the top here and the top here. How do I know for sure? What do you think the easiest way to know for sure is? To test points. If you were to test points, so for instance, what was this again? Negative 2. If I were to test negative 3, and by test I mean plug in. If I were to plug in negative 3, I should get a number larger than 3. If I were to test negative 3, I'll get a number larger than 3. That indicates to me that it's up here, right? If it was smaller than 3, then it would be down here. Does that make sense, people? I could test. So one of the ways to do that is to actually go to your y equals, put your function in. here's the way the graph looks, which is exactly what we thought. Remember, your graph does not put asymptotes. Okay, it does not. Actually, take that back. Sometimes it does, and it's really ugly because they'll actually connect like this. There'll be a dark line there, so students think that that's the actual function, but you have to know that that's an asymptote. Okay, and see, if you go to your table, you can see that, look, I have my errors where they're undefined at -2 and 2, which indicates to me that they're asymptotes. And if you look at -3, what did you get? 27/5, which is what? 5 point something. So isn't that bigger than 3? Which indicates that it's on the top part. Okay, it indicates that that's on the top part. So there you go. Okay, the biggest thing out of this is asymptotes. Do you remember how to find them? How do you find a horizontal asymptote? What do? You're comparing your degrees, right? And 3 things can happen. How do you find a vertical asymptote? Set the denominator equal to 0. And how do you find a slant asymptote? Long division, but there can't be a horizontal. Okay, there can't be a horizontal. Okay. All right. So let's finish this off. I want you to try this. I'm going to give you some time to try this on your own, and then we will come together. Okay. All right. How do I find horizontal asymptote? Compare the degrees. In this case, what happened? The top is greater than the bottom. So that means there is no horizontal asymptote. There is no ha. So the fact that there's no ha means what? There might be a slant. And how do I do that? Long division. Okay, so I'm going to kind of skip vertical for 1 second. Let's go down here to slant. And I have to divide. Do y'all remember how to do long division? Okay, so set it up for me. What does it look like? So inside the house is x squared plus 2x, and outside the house is x minus 1. And when you're dividing, when you're doing long division like this, you're really only looking at the what? You're really only looking at the front part, like that. Okay, you're really only looking at the front part. I realize that on the video you're not going to be able to see my hands covering this up, but you're looking at only x and x squared, correct? And so you're just dividing. So x squared divided by x, or you can think of it as x times what would give me x squared? Just x, right? So x. Now what do? Multiply it. You're going to take this x, and you're going to multiply it by this. So x times x minus 1 would give me what? Minus x. And then just like regular long division, what are you supposed to do now? You're going to subtract them, but when you're subtracting polynomials, the way you do that is by changing the signs. So this was a positive x squared, now it becomes negative, and this minus x becomes plus. And then now, look what's going to happen. These are going to cancel, and then you have 2x plus x, which is 3x, and then you do it again. Do it again. So, but again, you're only looking at the front. So x times what would give me 3x? 3, a positive 3. And now again, multiply. 3 times x minus 1 gives me 3x minus 3. But now again, I switch the signs. What's going to happen here? They cancel, and I'm left with positive 3. What is this? What is this? How do you know it's your remainder? There's no more x, right? So this, remember, you can never lose an x. You can never go lower. So like an example, let's just pretend that this was x squared, but this one was x cubed. I'm done because I can never go lower. Okay, I can never lose an x. And in this case, I would have to lose an x, right? So that is my remainder. But when it comes to slant asymptotes, I really don't even care about my remainder. My answer is up here. Okay, so my slant asymptote is a line. Y equals x plus 3. And it makes sense that it's a line because an asymptote is a straight line, isn't it? And a slant means that it's linear, right? Like that it has a slope and everything. So you could actually tell me what's the slope of this line and what's the y-intercept. 3. So 1, 2, 3. I know I touch here and it's going up 1 over 1, but it is a slant asymptote like this. Okay, so there's my slant asymptote. Is everybody good with that? Okay, let's talk about your vertical asymptote. Let's talk about your vertical asymptote. How do you find a vertical asymptote? It's just the denominator equal to 0. So in our case, x minus 1 equals to 0. So my va is what? X equals to 1. So you have a vertical asymptote at 1. So right here. So does everybody see how this looks kind of weird? Right? Does anybody know what this graph will look like? Because it has like a weird slant. You basically have two options. Because remember, they have to be kind of on opposite sides, right? There's basically two options. It's either going to look like this, or like this. Okay? It's either going to be this graph or the first one. How can I tell which one it's going to be? I got to find maybe my x and y intercepts, and I might even have to test points like we talked about in the other, right? So just to figure out, and you really only need about one test point, because once you know where one's at, like I said, you pretty much figure out the rest. Let's keep going. Let's try our x-intercept. Let's try our x-intercept. How do you find x-intercept? Y has to be 0, but again, because it's irrational, only look at the top. So it's going to look like this. 0 equals x squared plus 2x. So solve. Solve for x there. What would you do? Factor what? There's an x in both, so you can take out an x. If you do that, you have x plus 2. Now what can you do? Separate them and solve. Because remember, what this is saying is that the first thing times the second thing, is equal to 0. And the only way to multiply two things and get 0 is with 0. So separate and solve. So essentially you have two equations. X equals 0 and x plus 2 equals 0. Well, this one's already solved. And then what's my x equals negative 2? So I have two x-intercepts. I have two x-intercepts. One at negative 2 and one at 0. Okay? One at negative 2 and one at 0. And finally, let's talk about my y-intercept. How do I do that one? So it'll look like 0 squared plus 2 times 0 over 0 minus 1, which is 0 over negative 1, which is 0. So I do have a y-intercept at 0. I do have a y-intercept at 0, which is basically still the same thing. So does this tell me what my graph is going to look like now? Remember I told you pretty much only had two options. So it's going to look like this. And again, you can test points, or you can graph it and check your table out on the calculator. So it's going to look like that. Any questions? Again, the biggest thing out of here was, do you remember how to find your ha, your va, and your sa? Any questions?